Alrighty, we are back for another math lesson. Today, we're talking about combining like terms. What are we learning today? We're reviewing combining like terms. Why are we learning it? Because knowing how to identify like terms is a highly important skill for our first unit of polynomials. How will I know what I've learned it? When you can explain what makes terms like terms and explain how to add and subtract them properly. Our learning objectives: by the end of this lesson, you'll be able to identify like terms in algebraic expressions. You'll be able to simplify algebraic expressions by combining like terms, and you'll be able to apply the properties of addition and subtraction, to combine like terms correctly. So, what are we going to start with? We're going to start in box 1 here with a whole jumbled mess of an expression. 6x plus 3 minus 5x plus 8 plus 4x minus 4. And if you look in this, we'll see there are 3 things to note. There are variable terms. Variable terms are called such, you're not going to believe this, because they have variables in them. And remember that a term is anything separated by a addition or subtraction sign. Okay, it's an easy way to remember it. Anything separated by a plus or minus sign. So let's look for our terms that have variables in them. We have right here 7x. We have right here negative 5x. We have right here 4x. And whenever you talk about variable terms, you got to talk about coefficients. Coefficients are the numbers that are in front of the variable. Think of the prefix co. Think of words like co-worker, right? Someone who you work with. Co-teacher, someone who teaches with another person. Okay? Co as a prefix means with. So you're going to think of the number that is with a variable. So in this case, in our variable term 7x, our coefficient is 7. Our coefficient of negative 5x would be negative 5. And our coefficient of 4x would be 4. Okay? Now, we get to finally constant terms. Remember the word constant. Constant means that its value never changes, meaning that it's not attached to anything that's unknown. It is just a straight number. So, for example, 3. For example, 8. And for example, negative 1. Are all constant terms. So now let's talk about how we combine these like terms. Okay? We're going to go to box 2. We're going to write the same problem. The same expression. Okay? Now, to identify a like term, for something to be a like term, it has to have the same variable and the same exponent. The same variable and the same exponent. Now, a lot of people talk about different ways that you can do combining like terms. Some people like to draw lines under types. Some people like to surround them in shapes. What I personally like to do is I like to just start from the left and look for any like terms with what's on the left. So we're going to start with 7x. So I'm looking for anything that has the same variable and the same exponent. So anything that has a variable of x and only x and an exponent of 1. Because if you don't see an exponent, you assume it's 1. So we have negative 5x and we have positive 4x. When you combine like terms, you just follow the sign. So 7x minus 5. 7 minus 5 is 2. Plus 4 is 6. And when you're adding and subtracting, your variable and exponent just remain the same. So we're just going to put x. And now that we've used them, we're going to cross them out so we know that they're used. Then I move on to the next uncrossed out term, 3. That's a constant. It has no variable. So I look for all my other constants. Plus 8, minus 1. Okay. 3 plus 8 is 11. 11 minus 1 is 10. So your final answer is 6x plus 10. If you want to make a note here, if you're adding and subtracting, I'm writing in all caps because emphasis. The variable and exponent remain the same. I'm going to put that underline, underline, underline. If you are adding and subtracting, the variable and exponent remain the same. Why am I drilling that in? Because later, when we get to polynomials, we're going to talk about how to multiply them together. And in that case, the variable and exponent do not remain the same. So, if you are adding and subtracting, the variable and the exponent remain the same. That was the idea. Okay, let's go on to the we do. A little bit simpler. A little bit less going on. 7m minus 5m minus 6. So, what do I say to do? I start at my left side. Oops. I grab my first term, 7m. I say, does this have any like terms? Anything with the same variable and the same exponent. A variable of m with an exponent of 1. And I say, I do. I have negative 5m. So now I'm going to combine them. 7 minus 5 is 2m. Cross it out. All I have left is the minus 6. It has no one to combine with. It's all alone, all by itself on a Saturday night, much like myself. So it just comes down. 2m minus 6 is your answer. Okay, now we go on to you do together. So this is the one that you would be doing in class with your Math Wars team. I gave 2 minutes for this question. 2 minutes to really talk it over. 7p minus 1 minus 9p plus 5. And if you want to take this opportunity, set a 2-minute timer. Try to do this one yourself. Pause the video, set a 2-minute timer, and see what you come up with. All right, I'm going to assume that you are done, or you have paused the video. Okay. So, your answer should be negative 2p plus 4. That is ideally the answer that you got. How? Well, let's look. We start with 7p. And I say, all right, what like terms do I have? I have negative 9p. They both have p. So 7 minus 9 is negative 2. And when you add and subtract, the variable and the exponent remain the same, so it's just negative 2p. Cross, cross. Then you have your last term, negative 1 plus 5. Those are both constants. Negative 1 plus 5 is positive 4. All right. So let's move on to our next set of problems. This is another idea. Box 5, 8k squared minus k minus 5k plus 7 minus 2k squared. All right, so I'm still going to follow the same process, but now we have to worry about exponents. So remember, when I said a like term has to have the same variable and the same exponent. So I'm going to start on the left like I have been doing, 8k squared. Is k a like term with 8k squared? It's not, because the 8k squared has an exponent of 2, and this k does not. Is this negative 5k a like term? No, because it doesn't have the exponent of 2. 7 doesn't have a k at all. However, 2k squared is a like term. So we're going to combine them just by merging the coefficients. 8 minus 2 is 6. And then your exponent and variable remain the same. Cross it out to know that you used it. Now here we run into a situation. We have a k here. K doesn't have a coefficient. When a k, or any variable, does not have a coefficient, you assume that coefficient to be 1. So now I'm going to look. Do I have any like terms with k? I have negative 5k. That's a like term. They both had k and no exponent. 7, again, constant. So I do negative 1 minus 5. Go back to the trusty old calculator. Negative 1 minus 5. Negative 6. K. One thing to note when you're putting negatives into the calculator, if the negative is leading, like it is for the 1 here, you have to make sure that you are hitting the negative button on the calculator, or the calculator will be unhappy. If you try to do minus 1, minus 5, first off, is going to bring up the answer thing for your previous answer, so that's going to throw you off. But even if you get rid of that and you put it in like that, it's going to be unhappy because it thinks you're trying to subtract something from something that doesn't exist. So the leading number has to be negative 1. Negative. Then anything after that that's not a leading number, you can use subtract, minus 5. Because if you try to do negative 1, negative 5, it's also going to be upset. So for the leading number only, it has to be negative. Negative 1. Any number after that, any other negative number after that, minus. Okay? So that's done. The only term we have left, the plus 7, has nothing to pair with, so it just comes down. All right. We've used all of our terms. We're done. Let's go to box 6. So we do x squared plus 2xy minus 7xy plus 4y squared. This tripped up a few people in class, so think about this one. Okay. Let's start from the left. X squared. Do we have any like terms? No. This has a y in addition to the x, and the x isn't even squared. How dare it? This has an x that, once again, how dare it not be squared, also has a y. I mean, this has a square, but that's a y, so that's not great. So that's just going to come down. So 2xy, does that have any like terms? It does, with this negative 7xy. They both have x, they both have y, neither of them have exponents, so you're just going to combine. You're just going to push them together. 2 minus 7 is negative 5xy. Cross out, cross out. Is 4y squared, all by itself. Drop out. Now, I want to make sure that I note that if this were 4y and not 4y squared, it would still not be like terms with 2xy because this has an x and this does not. So because it doesn't have the exact same variables, it's not like terms. So you can't do that. Don't do that. has to have the exact same variables with the exact same exponents. All right. One problem left. I'm just going to do it on a plain sheet of paper. Let's do it. We have 4x squared minus 7 plus 2x minus 3x squared plus 8x minus 6. A lot happened. Okay, so this was a you-do. I gave 4 minutes for this question. So if you want to set a timer for 4 minutes and give it a shot, by all means, go for it. Pause the video and do so. All right. So assuming you paused the video and tried it, your answer should be x squared plus 10x minus 13. If you got that, good job. If not, let's talk about how. We start on the left, 4x squared. Remember, in order for it to be a like term, it has to match exact variables and exponents. So I can only take x squares. The only other x squared I have is over here, the negative 3x squared. So I'm going to combine these by squishing the coefficients together. 4 minus 3 is 1 x squared. You can put the 1. You don't have to. It's seen as redundant, meaning unnecessary. However, you will never be wrong for putting the 1x squared. Or if you just want to leave it as x squared, as I did in this answer, you can do that as well. Moving on, our next term, negative 7. We're looking for constants. The only other constant we have is negative 6. Negative 7 minus 6 is negative 13. And you cross and you cross. And then finally, we have 2x and we have 8x, both like terms because they both have x. 2 plus 8 is 10. And that is your answer. Putting them in either order will work for now. Later, we're going to learn about standard form, which would require the answer to be written like this. However, for now, if you've got this, that's perfectly fine. It works out. So that is your review on combining like terms. I hope it was helpful to you. If you have any more questions, as always, feel free to ask me in class. I'm absolutely here to help you out. Thank you for watching, because it means it's taking initiative on your own learning, which is important. So thank you, and I will see you in class.